How's it going, everybody? And welcome back to our Cisco Enterprise series. We're focusing on the fundamentals in this video, and I'm going to be diving in a little bit into the need for private IPv4 addressing. But I don't think I showed this in the previous video, but I kind of went through and did like a blueprint breakdown. So we've already covered dotted decimal, binary, bytes, bits, RFC 1918 space for 10/8, and breaking down how RFC 1918 works. And we did the endpoint count for subnet sizing and all that type of stuff. So in this video, I'm going to basically kind of describe the need for private IPv4 addressing, and then I'm also going to talk about public use as well and how that comes into play. And then we'll get into a little bit of link local and then loopback ranges and how that kind of works with the PIPA range 169.254, the automatic private IP addressing, automatic private IP address, a PIPA. So, and then we'll do some IPv6 we'll cover IPv6 in a different video, but we'll definitely cover that. So I'm going to keep this on the screen just for a moment as I kind of give you kind of the breakdown for this. So the need for IPv4 addressing is private IP addressing is still necessary in a lot of different environments. I'd say over my career, I have not seen very much IPv6, very, very little of it. And the only time I really got any real exposure to it was when I went to go to work for a colo that I did some work for several years ago that had an IPv6 footprint. And it was a small one, but it was still a footprint. So I understand how IPv6 works. I know IPv6 routing. I can get IPv6 running if I need to. But I'll say for the bulk of my career, IPv4 was the only the only address family that was ever needed. And when I say address family, there's two different address families. You have IPv6 and you have IPv4. So then you have subsequent address families like unicast, multicast, VPN v4, VPN v6, so on and so forth, multicast, MVPN, L2 VPN, stuff like that. We'll get more into that when we get further into the role of meat and taters of how networking works. But describe the need for IPv4 addressing, private. So the bulk of the customers that I've worked with, I'd say 80+% of them, they have a private IP address, IPv4 address scheme in place, and that's how their environment operates. Whether it's the 10net 172.16/12 or the 192.168/16. RFC. If you hear me use the term RFC 1918, that's what I'm referencing. Is the 10/8 172.16/12 and the 192.168/16. So if you hear that, then you know where I'm coming from. So I'll use RFC 1918, and then that encompasses those address blocks. So there's a block of, there's an RFC 1918 instance deployed, and that's how all their networking works. Whether it's a good design, a bad design, or something in between, that's the design the customer has gone with. Okay, great. When you are dealing with private IP addressing, regardless if it's v4 or v6, but we're going to focus on v4, that networking on its own is going to work only inside of the environment that it's deployed in. If you want to go out to the internet for some reason, for any one of probably 10 billion reasons, then you'll need a way to get there. And here's the biggest caveat of them all: you can't run a private IP address on the internet. It's not allowed. And there's a number of best practices, de facto standards out there that will explain why you can't do that. So there's different IP address blocks. Service providers will just block the traffic if you try to come in with a private IP address. Simple as that. So when you do that, you have to take into consideration, okay, what do I need in order for me to get to the internet? And the answer to that question is you'll need to translate your private IP address into a public IP address, which is where I'm going to get into how public addressing works. And I'm actually going to pull back up one note, and I'll share this out with you guys. I'll put it like in the description or something like that. So give me 1 second. So when we talk about that, and I'm going to go ahead and I'm going to get it out of the way. And can I blow this up? Yes, perfect. Let me go ahead and scoot this over so you guys can see it all. Okay, so we're going to talk about public use, because private IP addressing, I really don't want to dive a ton into that specifically, because we're going to be taking a look at how that differentiates when you get to the internet and use things like NAT, network address translation. What I want to focus on here is public use. What does RIPE, IANA, ARIN, APNIC, auctions, address transfers, and justifications, what does all that mean? So essentially what that means is, if I need, there's two different schools of thought. So you have I go out to a service provider and I get a internet circuit from them. I don't care who the provider is. It could be AT&T, it could be Spectrum, it could be Verizon, it could be Lumen. It doesn't matter to me. I don't care. As long as whoever can provide you internet access in your area. Now there's residential internet, and then you have business internet. What is the difference between the two? Well, in most cases, they're riding the same infrastructure. The only difference between the two is one is best practice, where the other one has a little bit of QoS prioritization. So at least that's how some service providers do treat it that way. So for example, I have Spectrum here at home, and I know that Spectrum Enterprise, they will give a little bit of prioritization to business internet customers. If you're a residential internet customer, you get no prioritization. You are going to go out to the internet and you're going to get what they call best effort. You're going to get zeroized. If you have any QoS tagging on any of your traffic, it's going to get zeroized, reset to zero. It's going to get remarked and sent across the internet as type 0 marking. The DSCP value will be 0. So, but with the business internet, you are going to get a little bit of prioritization. So your business internet is typically going to be prioritized over residential internet, and for obvious reasons. Your business, you're trying to, you're trying to do internet, and yes, I know there's every provider across the country has their own level of issue. So what I don't want you doing at that point is dropping a bunch of comments in here and telling me which internet provider sucks and this provider gave you a whole bunch of problems. Not the point. If anybody comments stuff like that in the comment section, I'm just going to delete the comment. It's like, that's not the point of this video. The point of this video is to help you understand the public addressing space and how companies can utilize that. So you can go out and get a commodity internet circuit, broadband internet, whether that's cable, DSL, some sort of fiber, 4G LTE for wireless internet, things like that. All of these options are available to you inside the US. So if you want to do just commodity internet, that's the way that you can do that. If you have a reason to go do anything bigger than that, so you want to have a global presence on the internet, and the key thing is global presence. If you're trying to do anything big, and regardless of what that thing is, I don't care. If you're trying to do anything and you need an internet footprint and you want to own your own address space, it is totally possible to do that. Now, I will be honest with you, getting public IP address space is becoming increasingly more and more difficult. And you might say, well, where would I go? What would I do? Well, there's this thing is known as an auction. You can go IPv4 auctions. You can Google for that, and there are websites out on the internet that will let you bid on an IPv4 address block as small as a /24. That's the smallest you can do on the public internet. Anything smaller than that, internet providers will not honor it. So what you do is you would go to the auction and you would go tell them, you would put a bid in, and then the customer would pay for it. You give them the credit card or a PO or a purchase order, something like that. They would buy that address block, whether it's /22, /23, /24, something along those lines. So you go to the auction, you select what you want, and it's going to give you, they're expensive. They're several $1,000s in size depending on how big of an address space you need and stuff like that. Now, that address block had already been handed over to another organization. So in most cases, Aaron, the assigned so I don't remember what Aaron stands for off the top of my head. I know IANA is the Internet Assigned Numbers Authority. So Aaron, American Registry for Internet Numbers. That's what Aaron stands for. AIRN, American Registry for Internet Numbers. Then you have RIPE is for IT. RIPE is the, I forget what RIPE stands for. Not that important. I know IANA is the Internet Assigned Numbers Authority. So those are governing bodies. Now I've done the most work with Aaron, so that's the most experience I have. So what you would do is once you've won the auction, then you need to go and, if you haven't already done so, you need to create a whois or a membership on Aaron. And the idea is you need to go through the transfer process of transferring the address block from whoever owns it and is selling it on the internet to you, and you need to do that through Aaron. Because before you can do anything with addressing, so like if you go out on Monday morning and you buy an address, you win an auction and you buy an address block. Let's say you spend $15,000. You win an address block. You don't get to go out that same day, that afternoon, and go plug in and go, I'm going to use my 42.16.31.0/24 network. It doesn't work that way. You can't do that. It's actually against the law. You can't do that. So it's a big no-no for the internet. Internet police will come knocking at your door. So what ends up happening is you need to do an address transfer from one organization to the other with inside of Aaron. That's who I've worked with a few times in the past. It's a very common thing to do address transfers once you've won an auction. But there is a process that you have to go through on the back end. You have to submit a justification. A justification is typically going to be like a spreadsheet, and you have to lay out the address range that you're going to be using and put in there what IP addresses are going to be using and stuff like that. You have to be automatically using a certain amount of IPs and stuff like that. And and recently they've added it to where you can't just be peering to one provider. You have to be peering to two. So in most cases, you're going to buy a /23. So you have two /24s that you'll be leveraging. You'll have one public address going to one provider, one /24 going to the other provider, and you'll be dual homed. So, well, in this case here, if you're connecting to more than one provider from the same device, it's referred to as multi-homing. Dual homing is same provider, two connections. But we'll talk more about that in BGP when it comes to internet connectivity. So when we talk about address transfers, you have to go through Aaron, you have to put through the process, and this all costs money, right? There is a charge for this. And typically at the exact same time that you're doing the address transfer from one organization to the other, you're more than likely going to be requesting a BGP autonomous system number at the exact same time. So once you go through that process, the address transfer takes usually about 2 weeks. Once you've gone through that piece and you've got that done, the next thing you're going to go do is, and you submitted your justification, you're kind of in a waiting game. So fast forward 2 weeks, the address space has been transferred from one org to the other. It starts showing up in your Aaron membership when you go log in, and you can see where it's at. Once that piece is done, then you'll go through, and same thing with BGP. You'll get a BGP ASN. You'll have to provide justification for that as well. Once you've gone through that, you'll go through and do a then you'll be able to start implementing. So that's when you reach out to the provider and go, hey guys, I want to leverage BGP on this circuit, and they will come together and you'll exchange some information. You have to put in a request to the provider to do, there's an LOA, a letter of authorization that you have to go through, and that is going to basically give the provider permission to peer with you, and vice versa. It's a legal agreement. So once you go through that, So let's say that whole process takes a month from the time that you get started till the time that you're on the phone with the provider doing the stand-up. So all these things are needed in order for this to happen. Now, ordinarily speaking, it's not overly complicated to get the process done. But I've run into some hiccups in the past where I'm trying to find whatever it is that I'm looking for and I can't find it, stuff like that. And you have to call into support and be like, "Hey, I'm trying to do this. What's the hang up?" Stuff like that. I've never worked in AppNic and I've never done anything with IANA. So I only have experience with Aaron. So I have tried with Ripe. It didn't work. So at least we went through the minutia of trying to get something to operate, but there's an issue with the address block or whatever. But that's not important at the moment. So that is the thing to keep in the back of your mind when you're talking about addressing and the space and how that comes into place. Is you've got to get the auction, and usually there's going to be, this is all built in the statement of work. The customer is going to be on the hook for buying all these things. You're just going to facilitate it and reach out to the auctioneer, get the address space. You're going to, if they don't already have an Aaron footprint, you're going to build an Aaron footprint for them, get all the information built out. There's going to be there's some legal documentation that they have to provide to Aaron to validate they are who they say they are. I don't remember what that is because it's been so long. And then standing up the service, the BGP peering to the service provider, which is actually kind of an interesting thing. When you start doing that, whoops, that was weird. There's usually an issue. There's two schools of thought when you talk about internet peerings. So you have provider independent and provider aggregated. Provider aggregated means that you are buying an internet circuit from the provider, and that public address space they are announcing to the internet on behalf of you. So, like your home internet right now, my home internet circuit, I have an internet circuit, and the job of that of advertising my public address space is on Spectrum. They advertise it to the global internet, and then everybody's happy. I can get to the internet all day long. Now, if you decide to go and stand up and get your own address space and do all that type of stuff, go through Aaron, go through the justifications, get your BGP autonomous system number, all that fun stuff, great. And you do the same thing through IPv6. Aaron assigns you your IPv6 address space and your BGP autonomous system number. So you go through all these steps and you get that all stood up. If you're going to stand up your own BGP peering with your own ASN and your own public address space, then it's considered provider independent, meaning that you're doing the advertisement to the provider. They're just allowing to get passed through. So that's essentially how that comes up. Provider aggregated means they're advertising it for you. Provider independent means that you're peering with them, but you're doing the advertisement. That's how that comes into play. Now, there are some cases with doing things like denial of service protection through like Cloudflare. I've worked with Cloudflare a bunch of times in the past, where for for incoming traffic to go through Cloudflare's environment and for them to do DDoS and internet scrubbing to try to remove DDoS attacks and things like that, you won't advertise the subnet anymore. They'll advertise the subnet for you, and then they'll just tunnel that traffic back to you, to your routers. That's how usually that works. And we'll talk more about that when we get into how that comes into play. I'll try to make a mental note to dive into that a little bit more, but that's essentially what you end up doing. If you go through a Cloudflare or any DDoS protection that's not given to you by your provider, most providers have some sort of DDoS distributed denial of service protection that's out there. And because the idea distributed DDoS attacks are typically inbound from the internet towards a particular IP, and by them owning and advertising that public address space, you don't become potentially a target of a DDoS attack. So, which it makes your job easier. You don't have to sit there and get a phone call at whatever time of the day. That the routers on the edge or the firewalls on the edge are spiking on the CPU because they're getting hit with tens of thousands of pings per second, or whatever the case might be. So that's where that would come into play. So beyond that, that is pretty much what I wanted to describe to you guys in this particular case. Beyond that, there's really not much to it beyond that. So there are cases where, well, I wanted to take a step back. DDoS isn't limited to Cloudflare. So when we talk about denial of service, and I'm not trying to jump ahead in security, but it's specific to public, when customers own their own address space and they're announcing through the provider, when you do that, the risk you run is that somebody on the internet, you might piss somebody off and they could start attacking you on the internet. That's why you try not to make enemies with people online. So anyway, when you run into situations like that, if you're peering directly to the provider and you're not doing some sort of Cloudflare or DDoS service with whoever, what you can do is most providers have some sort of scrubbing or DDoS protection. So when I say that, there's two different types of DDoS protection that service providers can use. You have the remotely triggered black hole, or RTBH, and then you have the remotely triggered sinkhole, or RTSH. And the difference between a black hole and a sinkhole is a black hole is just dropping the traffic, where a sinkhole is redirecting the traffic to a particular place inside the provider's network that can handle that and then inspect the traffic. So you'll hear this thing called flex or flow, BGP flow something. Hold on one second. Flow spec. So BGP flow spec is a way of handling that. It provides you like a DDoS mitigation capability. And the idea is most providers will, if you're going to do it, it's one of those things where you want them to be proactive. So they'll have inspected your traffic long enough to know what's normal traffic. And then beyond that, if there's an attack of some sort or anomalous behavior on the environment or on the network or for your IP address or whatever it might be, if there's anomalous traffic, what will end up happening is instead of that the routers that are connected to you advertising the subnet for you, what will end up happening is that router advertisement will stop, and then the internet scrubbers, the DDoS protection mechanism, that will start advertising your subnet on your behalf. So it's a redirect. So the traffic is being redirected to where the traffic can be handled appropriately, and then clean traffic is extrapolated from that and then redirected to you. So you get the clean traffic. That's how DDoS mitigation usually works. So if you want to know more about that, you can go always look up what they call an arbiter, 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 and how that comes into play and protects you on the network side. So that's pretty much what I wanted to talk about in this video and lay down some of the basics to how all that type of stuff comes into play. I'm not going to take you through an in-depth discussion on that because, well, I just want to kind of lay the groundwork, because that's one thing that a lot of people don't teach, is explain how public use comes into play. So if you have any questions on that, comments, feedback, whatever, drop a comment in the comment section below. And if you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video. Have a good one, everybody.